Good morning, everyone. Welcome to Plenary number 6, titled ISS and Beyond, the Future of Human Activity in Low Earth Orbit. This is the future panel, so in case you want to know what's coming up next, this is the right place to be. Look at our distinguished guests we're having here. Of course, they should really know what will be going on. This is going to be an interactive panel. So from the terms of logistics, I ask you all to have questions. Have these questions written on a piece of paper, which will be collected by charming ladies here, Gia here, and Charlotte just in the back. And I will get them and will try to answer them in a most concise way as possible. So what we intend to do is we have a small introduction round at the beginning. Then we have Q&As over here, Q&As with you, and then we have an expo. And hopefully you all go out and say, it's going to be a bright future, and not a dim future. It's going to be a bright future at the very end. So, as said, we have distinguished speakers, panelists, and I may introduce the first person here, a German speaker, Hans-Jörg Titus, member of the executive board responsible for space research and technology at the German Aerospace Center in Köln. In case you want to learn a bit of German, that is called Vorstand für Raumfahrt. Hans-Jörg had his primary education in Stuttgart, his university education in the area of physics and geophysics at the Ludwig-Maximilians University in Munich. And having finished his studies with a PhD, his scientific career would lead him eventually to Bremen, where he served since 1990 as Deputy Institute Director at the Center for Applied Space Technology and Microgravity TARM. That's the tower, the drop tower, the big drop tower at the University of Bremen in Germany. For those who were at the German evening, you know that the Germans are keen football players. And you've heard that maybe that the Germans have taken the Bundesliga approach to space. You have Bremen there, you have Stuttgart there, you have Berlin there, and sometimes you get the feeling they're playing a bit of a football match over there. So looking at Hans-Jörg, coming from Stuttgart, moving on to Munich, and finally on to Bremen, I really wonder what his heart's beat for. Hans-Jörg, the stage is yours.
Thank you for this long introduction. And you asked about 3 statements about space station, a future, and I restricted it to that. So the first I like to show you is, does it work? Yeah. I like to show pictures and ask a question, what do we see? And we see, and by the way, I should say this picture is of course taken from space station. What we see is the limb of our atmosphere. You see the atmosphere, the very thin layer in where life on Earth takes place, and it's, I think, close to our heart to protect and at least observe this very thin layer. Whatever climate change will influence, we see the indications first of all there. Climate change and its dramatic consequences is a great challenge of our society, but we use ISS much too less, in my opinion, for the great challenges of our society. That's my first statement. And I have a second one. And I asked the question first, what do we have? We have these ISS. And these ISS flies over all industrial hotspots worldwide, below 50 degree north and south. And the question is, where are the sensors, where are all the sensors, the telescopes, the spectrometers, the LiDARs, limb observation instruments on this station to monitor trace gases, emissions, and guard the promises given by our governments in order to reduce pollution. And the statement is the ISS, the largest infrastructure in space, is used so far well beyond its capabilities and options. So the third is, what do we need in the future? And I think we need more observation on a space station. I think the space station should more observatory than only laboratory operation. And therefore we think on concepts, more modular concepts. And I like this paradigm shift that we talk about observatories on space rather than on laboratories in space. Societal challenges, for example, climate change needs not only international agreements, but even control and monitoring, say observation. So we need a modular space observatory open for all, in particular for all nations, not only for the club of some societies. So, and modular means separation of tasks in separate modules, information flight, some standardization, but never complex space structures. And this is open then for private and public services if we can agree on some simple interfaces and transport concepts. That's my third statement. Thank you very much.
Well, Hans-Jörg, thanks a lot for that. The second speaker is Mike Gold. He currently serves as Bigelow Aerospace Director of DC Operations and Business Growth. He's responsible for a broad array of activities at Bigelow Aerospace, including international business development, export control, media, corporate, and federal relations, as well as NASA Space Act Agreement implementation, patent report maintenance, and strategic planning. Prior to joining Bigelow Aerospace in a full-time capacity, Mr. Gold previously assisted the company as an attorney in Washington office. While working over there, he supported several clients in high-tech and education-related fields with a specialty in advanced aerospace ventures. Mike is a real lawyer. He's licensed to practice law in the District of Columbia, New York State, and graduated from the University of Pennsylvania Law School, where he founded and served as the first coordinating editor of the Journal of Constitutional Law. Now, I do not know how many of you have been in the commercial spaceflight panel, but if you have been there, you might have seen that Mike is obviously a keen Star Trek man. So I wonder whether we'll see any reference to Star Trek over here as well. Mike, stage is yours.
Thank you so much to the IAC and to Norbert. I particularly appreciate this slide in that picture, which had to be at least from 5 years and 40 pounds ago, so I'm sorry to disappoint with that. If we could go to the next slide for my first statement. Oh, wonderful. So my first statement is that the private sector has the experience and ability to support low Earth orbit operations. As you may have heard at my first panel, Bigelow Aerospace has already launched 2 prototype spacecraft, Genesis 1 and Genesis 2, in 2006 and 2007. Those launches were conducted via a unique collaboration between Russia and Ukraine via the country Cosmotros. And let me tell you, I sure am glad we're not doing those launches right now. We will be conducting a third launch, the Bigelow Expandable Activity Module, which will be going to the International Space Station next year. So we alone at Bigelow Aerospace will have launched 3 spacecraft. We'll have our first crew demonstration going by next year, and we can support crewed LEO operations. My second statement is expanding upon that. LEO will become a commercial domain. And maybe it's difficult to see at this point, but if you go back to the telecom sector, there was a time when every communication satellite was owned and operated by the government, and there weren't many, maybe a half dozen. But when the private sector gained the ability to develop, create, deploy satellites, the next thing you know, we're employing tens of thousands of individuals. We have an industry that's generating hundreds of millions, if not billions of dollars, and technologies that impact us every day, every moment of our life. That can, and I believe will happen when it comes to crewed operations in LEO, in partnership with our colleagues in government, and in the American case with NASA. My final slide and final statement is, for that future to happen, we must overcome the barriers and what separates us. And since this is the IAC, let's begin at a global level. As I described yesterday, second only to gravity, the ITAR had the greatest chance to prevent us from leaving Earth. And that's not uniquely American. We have a variety of situations throughout the world that prevent us from coming together as a people. There was a lot of skepticism that we could ever get beyond the ITAR, but we did in the US. Norbert was kind enough to mention my legal background. We filed really the first legal challenge to the ITAR in a crewed context, and it took 2 years, but we were successful. So these things can change. But even going beyond the international barriers, we as an industry need to come together. We cannot fight the new space versus old space battle, traditional versus new companies. The pie is too small. We need to come together as space enthusiasts, as space companies and those who are dedicated to going into the final frontier, be it companies, countries, and the vision for that has always been Star Trek. I like to say if you applied the ITAR to Star Trek, Scotty is a UK citizen, couldn't talk to Sulu, who's Japanese. Chekhov probably couldn't have gotten a visa this time around. And I have no idea what you do with ITAR with a Vulcan. So we need to get beyond that. I believe we can. We need to work together, small company, large company, domestic, international. And I know I'm in Canada, but to quote a great American patriot, if we don't hang together, we will surely hang separately.
Wow. Thanks a lot, Mike. Mike, I'm just wondering, this nice baby suit that the baby was wearing, do you have to really all the time on, or is it just really taken for this picture?
Let's say I'm normally in a Star Trek uniform. So.
Okay, even for the small sizes. So we come to the third speaker, that's William Gerstenmaier. He's the Associate Administrator for the Human Exploration and Operations Directorate at NASA headquarters in Washington, D.C. In this position, Bill provides strategic directions for all aspects of NASA's human exploration of space and cross-agency space support functions of space communications and space launch services. He provides programmatic direction for the continued operation and utilization of the ISS, development for the Space Launch System and the Orion spacecraft. And he's providing strategic guidance and direction for the commercial crew and cargo programs that will provide logistics and crew transportation for the ISS. Bill, I had NASA written afterwards, sorry. Bill began his NASA career in 1977 at the then Lewis Research Center in Cleveland, Ohio, and he was performing aeronautical research in wind tunnels originally. He later on worked on the space shuttle and served as the Shuttle Mir program operations manager as well, so certainly a really, really, really experienced person. Bill is certainly one of the persons that have a very swift response, so when I worked on the slides, we had some of the issues coming up, and he's really one of the new generation, you could call him, because I dropped him an email saying I need some update of the slides, and I got a response within 1 minute. I don't know any administrator in the world who is so fast. I assume he's probably a rather hard boss to work with. Hi, Bill. The floor is yours.
Okay, thank you very much. Let's talk a little bit what we see beyond space station. First of all, the things we're trying to do with station is establish the ability for commercial industry to use low Earth orbit. So part of that activity is first transportation. You can see that with the picture in the upper right-hand corner and the lower left-hand corner. Dragon and the Cygnus capsules being captured by the robotic arm on board space station and attached to station. So the first step was to make sure that the transportation was available, so if a commercial company wanted to go to low Earth orbit and use low Earth orbit research, they had an ability to do transportation. We just made the award for crew transportation commercially. Again, NASA doesn't own the capsules, doesn't own the transportation systems. It's available to the commercial sector to go use. So we've got the basic transportation enabled for the commercial companies to use. We're also experimenting with Bigelow, as Mike talked about a little bit. Next year, we'll get a chance to see what the expandable module looks like on station, how it operates, look at the thermal properties, look at how radiation is, get some crew inside to see what it's like from a human factor standpoint. I think that'll be tremendously important information as we start planning for spacecraft beyond space station. And then down in the right-hand corner is a little surprising thing. These are the CubeSats that we deploy from space station. I would have never guessed there would be a market for CubeSat deploys from space station. I would have thought that CubeSats can be deployed off of any expendable launch vehicle and everybody would go do that. I now have companies and universities and students that are actually turning down a guaranteed launch on an expendable launch vehicle to go to the space station to be deployed from the space station. This is incomprehensible to me. This has something to do with branding and the fact that they want to have a picture of an astronaut with their CubeSat getting loaded into the launcher before it goes out through the Japanese airlock to be deployed from space station. So they're willing to forego what I would consider an immediate opportunity to get their little spacecraft in orbit to get it off of space station. So this is something that I think the commercial sector can do much better than the government. They can understand what makes sense from a branding standpoint, and they can utilize low Earth orbit. There are lots of things that we're going to need from a government and NASA perspective. We're working on refueling, solar arrays, leak detection, rendezvous sensors, EVA systems, docking systems, trash compactors. These things are things that we need, and we're getting these from industry. We're getting them in a slightly different way with all these. We're looking to team with industry to put these things in place. But we can use this equipment and this hardware in space. Then the next piece is we've really got a finite window with this space station to establish a market in low Earth orbit. We need to let terrestrial companies see that there's real benefits of doing research in space. And that's kind of this discovery little circle that I have up there. That's where we see interesting properties in how bacteria perform in space. They definitely operate differently. The human immune system is less effective in space. There's bone loss, muscle wasting, all these things occur in space, and the microgravity environment gives terrestrial researchers a unique window into all these properties, and then they can potentially take that to economic advantage to gain competitive advantage in the world. So one of our primary purposes near term is to expose as many terrestrial companies as we can to the benefits of space. Let them discover what they can get from research. Let them see this huge potential from space-based research. Then with enabled transportation, enabled cargo, they can then go operate in low Earth orbit. And on the right-hand side, I show some terrestrial examples of things that have come from space station. One is NeuroArm, where we're able to do robotic surgery now using essentially the techniques that were pioneered kind of in space activities. You know, things that we take, for example, when we go capture a free flyer, there's a keep-out zone of where the arm can move. We were able to work with the surgeons and actually put keep-out zones as they use a robotic device to do surgery. So there were certain areas in the brain where they would typically not operate because the potential of going into, say, the communications area of the brain, they wouldn't go anywhere near that area, but we were able to work, the Canadian group, MDA, was able to work with the surgeons here and actually build keep-out zones within the software. So the surgeon, as he's manipulating this fine manipulator into the brain, it cannot go into those regions that you don't want to touch, such as the communication center. So it allows the surgeon to perform surgery that could not be performed without robotic assist. And that became natural to us. You know, we have a corridors we approach, we do arms, keep-out zones, all those things. We do that all the time, but then for us to expose that to the medical community and show them how they could use that was a tremendous benefit. Mr. Dedas talked a little bit about Earth observation. We think that's a really strong case. Rapid Scat is about ready to get turned on today on board Space Station. We'll get a chance to see how that operates. And in the bottom picture is just some materials processes where we're actually looking at some turbine manufacturing or turbine blades. Again, without convection in space, you can get some interesting material properties, and then that can be applied here to the ground. So it's not about building things in space as much as it about using space to see how properties can change, give us a different window in. Then these companies can gain new manufacturing techniques, new processes, new pharmaceutical drugs, et cetera, terrestrially. So that's the key of station right now is can we show terrestrial companies there is a reason for them to be in space, and this benefit from space is worth their investment in the future for potentially a commercial space station. And then this is my last picture, and this is more of a concept thing. It's interesting when the crews come home now to Kazakhstan and they land, they state their home. So even if you're from the US or you're from Russia or from Germany, when Alexander Gerst comes home, when they land in Kazakhstan, the expression is, I'm home. So we've changed the definition of home. So it's no longer where you live in your street and your potential city or your country. The world is now home. The Earth, the surface of the Earth is now home. My vision is someday low Earth orbit or even cislunar space becomes home to us. So when we're returning from Mars or we're returning from a far destination, and now we're in either cislunar space or we're in orbit around the Earth, when we start calling that home, we have done something real and we've made a change in the future. The other thing you'll notice on this picture down in the little lower left-hand corner is a constellation Orion rising through the Earth's atmosphere. So in this picture, I was able to capture Orion, the space station, and potentially the future, and someday we need to call this home. Thanks.
Wow. Wow, that was a nice philosophical closing. I suppose that will provoke a lot of questions over here as well. Remember, we had Star Trek before, we had like philosophy now in the back. Go with your questions, think boldly when no one has thought before. No question is silly. We'll filter that one out anyway. Bernd does this in the front, so if it's too silly, he will take it away anyway. Don't worry. So originally, if you look in the programs, you had a Chinese presenter here on stage as well, a panelist. Unfortunately, had to drop out in the very last minute, so that leaves us with four distinguished speakers. And so the last one to close this introductory session is then Professor Ernst Messerschmidt, a science astronaut aboard the Space Shuttle D1 Spacelab mission in 1985. He has designed and implemented many unique space experiments, performed about Spacelab and space stations. Since 1986, he has been director of the Institute of Space Systems at the University of Stuttgart, serving also as dean and vice president. From 2000 to 2004, he has been on leave from the university, and he led the European Astronaut Center of ESA in Cologne. His research specialities include the architecture of space stations, reusable space transportation systems, and planetary transfer vehicles. He owns 10 patents, wrote more or less 150 journal papers, and authored 10 books, a real professor. Well, I'm really looking forward to his statements now, because this gentleman, after all, has been the fastest on the panel. At least he moved with 88 kilometers a second. According to Albert Einstein, that has propelled him a bit into the future. Exactly the right man we need now. Ernst?
Thank you, Norbert, for this kind introduction. Talking of the home we may share in the future in low Earth orbit or some other place, how is this home going to look like? My first statement is a question or a statement, I don't know. Because what we are going to prepare for future exploration missions, that is not yet well defined. We have to talk about the destinations, we have to talk about the launchers, and of course heavy lift launchers are the basis for the decision of the looking of the transportation system. And the future space station is very mobile. It's not just circling around the Earth. It is a space transportation system. Additional functions, of course, like powerful propulsion systems. But again, everything depends on the destination. So this is an artist's view from an ESA artist, and of course, a future space transportation system is a sort of a ship. And even the sails may be realistic in the future once we talk about solar sail propulsion. At least electric propulsion is an option in the future for cargo missions. And the destinations, when we talk about destinations, this is my second statement, it's rather limited. Those destinations we look at for the next couple of decades are given here. It's back to the moon. It is to one of the libration points close to Earth. We have 5 libration points in the Earth lunar system, and another 2 the collinear ones in the Sun-Earth system. And it is important to know that all those 7 libration points close to Earth are about on the same level, energetic level. That means in the future, certainly our spaceships operate in that domain. And the question is how we come back eventually to reuse a spacecraft flying to one of those destinations, say to the Sun-Earth libration point, for example, to repair the telescopes. We have an inventory of tens of billions of dollars sitting over there, and the question is, why don't we service those and refurbish precious instruments in the future? For example, like eventually, I don't hope, Bill Gerstenmaier, that's going to happen for the James Webb Telescope. And or flying further to asteroids and ultimately to Mars or its moons, Phobos and Deimos. The question comes, and that's my third statement, what are the technologies we need eventually to reuse the spaceships or even talk about cycling spaceships. And here comes just one idea how it may look like. The upper left picture shows a typical transportation system that might be propelled to one of the lunar libration points, and or similar spaceships, for example, for missions lasting 1 year, 1 year and a half to asteroids. Why don't bring them back, for example, to our home in low Earth orbit? The question is how we manage this. If we do this propulsively, we would have to add 50% to the mass of a spaceship. And the question is why we wouldn't use a decelerator, a carbon shield in front of such a vehicle and design the whole vehicle in such a way that in a benign descent, maybe with multiple passes, we get to low Earth orbit without astronauts, because they would be separated in the sort of Orion capsule and then land independently of the transportation system. And that can be done only with an overhead of 10 to 20% of additional mass if the space station is designed correspondingly, such that, for example, radiators, etc., are in the wake of the re-entering spaceship. And such an operation would last about 2 to 3 months, and it is unmanned. Now, what we need, and that's my final statement in the future, is starting with the question, what are the future launchers? That's pretty much defined already as LS, Orion, we know, and all subsystems or some subsystems that are very critical also have been shown by Bill Gerstenmaier. But the real question is, what are the missions, and what are the objectives for utilization? And that, of course, that is threefold, as we have stated once in the cosmic study, even formulated as imperatives. That is to explore, to understand. You only start to understand when you're asked the right questions, and to unite, to do it all together, to Mars together. Thank you very much.
So, gentlemen, thanks a lot for the first introductory round. We have already the first question, which I think is really, very good question. It comes from Lockheed Martin. Moving forward, how do we ensure that there is support and momentum for both ISS and beyond LEO exploration? Hans-Jörg, just really a round question to everybody from different perspectives, from the administrator.
I can start, and then you guys can fill in here. I would say that I think a lot of times it gets cast as an either or. Is it space station or exploration? And it's really, I see them as both. We need space station to develop techniques for exploration, understand how the crew's going to be able to survive in a microgravity environment. Our systems we have on space station are not functional. They have a lot of maintenance required. We need to improve those systems. We must get much higher reliability systems, lower maintenance. And station is that really first step in exploration. Next year we'll have the 1 year increment on board station for the first time. And I think that's a chance to connect with the general population about how station can be used as that first step in exploration.
Mm-hmm. And if I can just draft off of what Bill said, we spend so much time in this industry trying to separate ourselves and attack ourselves. It isn't either or. They both have to happen. The beam is a wonderful example of this, that we have an expandable habitat technology that will be demonstrated on the International Space Station that will be critical for beyond LEO development. The SLS is a system that could match very well with expandable habitat technology. So let's stop asking the either-or question and figure out how both can complement each other so we can move forward.
Mm-hmm. I agree completely, but I think we should distinguish between the timescales on we are thinking. We have a short-term decisions to make now. I like to remember that Europe The European Space Agency has not decided upon the space station operation until 2020. With just commitments until 2018. And so I think the short-term discussions are very important, at least in Europe, and we need post-ISS to be defined as an upcoming station in near orbit, in low Earth orbit. Exploration is the next step, and it will come up, but the first is that we go back, or at least keep the ability to stay in low Earth orbit. And I think this is most important. So the time scale of the next 10 years is to think about a low Earth orbit station, and then to continue, hopefully, to exploration. But those are the time scales. And the budgets are very, very limited, at least in Europe.
Jens, anything? Okay.
Just to argue on the same line, the ISS is a perfect test bed to find the technologies we need to find our best infrastructure in the areas I have been talking about, up to Mars. And one example is the life support system. The question I have, for example, is it purely physical-chemical? We have tried out at our university to combine it with a biological system. For example, if you combine fuel cells with a bioreactor producing algae, the algae digest CO2 and produce oxygen. And the astronauts get even green food, salad or whatever, although the aquatic system are a factor of 5 to 10 times more efficient in transforming sunlight into food. Those are the kind of technologies we need in the future. We need better interfaces. If you look at the ISS, of course, we have two approaches, completely different. The EVA suits are different, pressures are different. The fluid handling from approaching spacecrafts, which certainly are your robotic in the future, are different or non-functioning, or in any way not available. So that is the kind of thing. And talking about money, we need, of course, the right approach and the resources. And also maybe a change in the announcement of opportunity for ISS. What I, as an engineer, was criticizing all the time is that there was rarely an announcement of opportunity for engineering sciences. Engineering sciences for ourselves, not only to find better subsystems for satellites, but for human spaceflight systems.
Now you have mentioned the commercial utilization, exploration, of course, science. So what's the current setup on the ISS? Is it like 30%, something like that? And how is this going to be changed in the future? Will we see more and more exploration coming up? On the expense of what, for example?
Again, on station, we have a tremendous capability to do a whole variety of research. So we're not lacking for facilities, space. We're not lacking for other activities. And we have to do both, right? We have to do things that we described that we want to do for exploration, but I think also because we ultimately owe the taxpayers some return, we need to do things that are benefiting folks on the Earth. So, we talk about off the Earth, for the Earth. So these biological things, understanding how pharmaceutical drugs might be manufactured are important. So we need to show that benefit too. So again, I think pulling on what Mike's saying is that we just need to not look at these as discrete items that are either or. How do we treat them as a total system? And then back to Ernst's comment, we grew for the first time, we grew lettuce for our crews to eat, right? And this is the first time we've ever done that. Before anything else we've always grown, we've grown it to understand how the plant grows. But this was the first time that we actually grew it to eat. Now, the only disappointing part was we had to freeze it and bring it back to the Earth to determine that it was safe for the crews to eat before we allowed them to eat it. So that kind of upset me a little bit, and I've been working with my teams to get a little more forward-leaning and said, couldn't they just eat a little bit of the lettuce and they might survive? So we'll see.
When I had my space flight, I had an experiment growing mice and look at the hormone transport. And we just needed a little bit of mice, and then, in fact, I also had, I think, some Italian sauce around, and I mixed that with the remainder of the experiment, and I added, so that was perfect.
Any other comments?
Yeah, okay, you asked the question, what is coming next, what is dominant? I think it's a question who pays for what. And of course, I can imagine that there is more private activity in space. So that's why we vote for modular concepts, so that we don't think about a huge station where we have to define utilization from the early beginning, but we vote for systems which are so flexible that it can be changed and adapted to the needs society is creating. But I think that there is a lot of public interest, at least to use a station, at least for observation, and also for experiments. We have wonderful ideas of new experiments, very challenging experiments, but they have to be paid, and we need the budgets, of course.
So I'm not a fan of lettuce. You can tell by looking at me. Grow a burger up there. I'll jump in. You know, again, we can't go this either-or route. Even if a commercial utilization activity has nothing to do with exploration, by generating that additional business, the launches, the economics of scale start to come into play that can enable you to go beyond LEO. You prove politically the value of space exploration, which allows you to fund the next step to go beyond LEO. So again, just echoing Mr. Gerstmeyer here, these aren't discrete parts. You have to look at them as a whole. And to the extent that you cut any of it out, you're just hindering yourself in a fashion that will bring down the entire endeavor.
Okay. So while we are deciding on the lengthening of the lifetime of the space station, at least in Europe, the Americans have already stated what they want to do. Of course, the Chinese are also building theirs. And there's a question related to that one. How do you think about the possibility of collaboration between the ISS and China Space, for example, using the China Shenzhou spaceship to transfer crews? Nobody dares?
Again, momentarily, right, we're prohibited from bilateral activities with the Chinese. And I think someday that will probably change, but for today, that's where we are. Again, I think there will come a time when we do cooperative things with the Chinese, and then how much we bring together is there. I think it's, when I look at this enterprise, like I described before, and I described home as landing in Kazakhstan, it really is this Earth, and really for all of us to go forward and do extensive exploration, it's going to have to be done internationally with essentially everyone participating. We'll figure out when the right time for all that occurs, and when it happens, our political governments have to make the right agreements above so we can remove those barriers and those restrictions. But I think it's up to us in the space community to show the benefits that we get by cooperation, the advances we can make by working together, how we gain a better understanding of each other, and then maybe the governments will see that positive work that we're doing, and maybe then they'll relax some of the constraints that sit on top of us today.
Mm-hmm.
I will say, having been active in the export control reform movement, China remains the third rail of ITAR politics. That any changes, relief that we're getting are not applicable to Chinese collaborations. And in Congress, I don't necessarily see that changing in the near term. You look at people like Congressman Wolf, Congressman Culberson, have some concerns about human rights issues that they will want to see addressed. But even as you look at, in Congress, some of the most ardent China hawks, what they really want to see is mutual benefit. And if you have a collaboration where NASA, America, benefits as much as China in their space program, I think you would see openness there, and that there's a bit of a door that's open that may have not been previously.
When we talk about space stations and human mankind in low Earth orbits, I think it's not a question of staying on one station all time with all nations. Why not having different modules at the same time in orbit? I think we only have to agree on transport possibilities, on interfaces, on docking systems, so that we can do some interchanges. Why bringing all on one station? I mean, this was maybe one of the concepts we should change, and this is one of the disadvantages of the big station, that if one jumps out, the whole system is breaking down. And so I think, why not doing the same time in parallel, having different modules, maybe information flight, maybe different. So I think this kind of flexibility we should have, and then we are also not vulnerable against all these political problems we face every day. I mean, we have not an easy situation at present, and I think this kind of cooperation should be possible in a better way if we think in modular systems.
Okay.
I think in the future, before we start discussing who is doing what, we need a model for international cooperation. And here also the question is how that could look like. Do we rely on dependency? That is a bit different looking at the ISS. The master of the ISS is NASA, that's for sure. And but that created a lot of redundancy in some areas where you don't want to have it. And of course, transportation, rockets, space stations are the most visible signs to represent a country. It also could be that we discuss of systems where we allocate functions to those that want to collaborate. Mm-hmm. And in such a top-down approach, we might also find better ways to get organized. But that would require that there is no single country that is only sitting in the driver's seat or having a share beyond 50%.
And I'd add one other thing that's really important is we're starting to put together some standards. So we have the International Docking Standard, which has been put together. And what's unique about that is it isn't a specific design. It is just a basic standard, and it's posted on the web, so there's no restrictions on it at all. It's open to everyone, and it's not a requirement. It's essentially a voluntary standard. So if you want to have compatibility with anybody else's spacecraft, all you have to do is build to these interfaces. It doesn't tell you what kind of hooks to have. It doesn't tell you, it tells you basic dimensions and what the forces need to be at capture. It's like a USB port on your computer. It's totally voluntary. So every country can build to that, and now there's ability for different spacecraft to all dock in orbit, and we didn't have to do anything from a exchange of control or designs or ITAR or anything. We can do that. So I think we need, and I probably need to, this conference is probably a great time for folks to talk about what other areas should be standard. And we can do voluntary standards like we do in spectrum, where we keep radio frequencies from interfering with each other. Again, a lot of that is voluntary. They're not mandatory. And there's many things that can happen without this, full authority to go decree and put things in place. So I think it's up to us to think about creatively, what are those key interfaces that could be standard that enables us to all operate in a much more effective manner?
Mm-hmm. Okay. So if you're thinking about the future, 10, 20 years in the future, if I was coming and giving you $100 billion, of course you would all be smiling, and asking you were to design the next space station, would you make again a check of all trades, or would you make it more specialized? How many partners would you involve? How much international would it be? Stuff like that. So what would be your really vision for the next generation of space station? How should it look like?
You will give us only 1 billion?
Good question. But we can negotiate.
I think that's the question, how we work together in the future. I mean, do we need all this, in my opinion, very complicated way of cooperation in ISS? And I think one lesson we learned from ISS is that it's nice to work together, and we need to work together. We have to cooperate, otherwise we will never go up to space. For example, Europe needs the capabilities of launching vehicles from the US, from Russia. In principle, what he had said, what Bill said, we need a modular system. So we should start individually, not to talk too much on international cooperation in a sense that we define whatever has to be defined, have to agree on experiments, have to agree on standards. So the first thing is we just set some standards and bring up the modules. Everyone can do whatever he is able to pay for. And if the private sector likes to jump in, it's easy to bring it in if we agree on standards. So the billion you like to give us is good. The question is to whom of us you give it, and then we can make these decisions, I think, individually. If you spread it over of all of us, then 300 million would be a bit, or 200 million would be a bit less to bring up a new module in space.
Well, according to your last question, I would be tempted to make an ITT with you guys and ask you to come up with some offers once in a while. But let's hear what our commercial man would have to say to that.
Well, clearly, all future stations must utilize expandable habitat technology. A question in my mind, so let's begin with that, is a threshold issue. I'd like to go back to what Professor Dittus was saying, and I think, Bill has spoken about this in the past, that we must decentralize LEO. It cannot be a single station dominated by a single country and a single space agency. I foresee a future of multiple stations, some of which may be government, some of which may be commercial, and some of which will be both. And per my slide, I see a transition in LEO from countries to companies. And I believe when the relationships are more business to business, or in some instances, government to business, that a great deal of the transaction costs and difficulties that we suffer with the monolithic system that we have today can and will change. And what I'm so excited by is that if we do that, it enables NASA, DLR, and global space agencies to go beyond LEO. Because in Star Trek, it's not about going around the Earth. It's about going forward. And by commercializing LEO, we can free up the resources to develop the technologies to conduct that mission.
Again, if you gave me all this money to do a low Earth orbit space station, I'd probably give you the money back. Because I don't think that's what we ought to be doing. I think we need to create a compelling vision where low Earth orbit is a place that commercial companies, the private sector, and the public want to go to, and they're willing to spend their own dollars to go get to low Earth orbit and do those activities. The government's role is to do the things that make not a whole lot of sense yet, right? And that's to push humans into the solar system, to go towards Mars, to push those really hard things, to take those really big risks that there's not even a little speck of potential payoff from this activity. It is just pure moving human presence into the solar system. But this low Earth orbit, we're close to this position where we need to show to the rest of the world that there is a reason why you want to go to low Earth orbit, how removing gravity from all the physical equations we deal with every day gives you a unique insight into material properties. It gives you a unique insight into processes that are dominated by convection. It really, and I want to see the research community see that and understand that that gives them competitive advantages and lets them build new products because they have better math models to build things here on the Earth. That's the vision I want to see. So we need to use this finite life of this space station we have, and I don't know where it is, but it'll end at some point. We've got a finite window, and I want to see then a series of maybe single purpose, but a series of smaller commercial space stations doing a whole variety of functions in low Earth orbit. And low Earth orbit is now an economic zone where there's new development, new research going on, and it's no longer the domain of governments. It's really the private sector pushing research out into low Earth orbit. So you get back your money, give it back to me, and I'm going exploring.
Okay. Fair trade. That was a great question on risk, obviously inspired by Mike. To boldly go where no one has gone before. How will we overcome our risk-averse tendencies given the constant public scrutiny of our connected world? So risk is the big issue. How do we overcome that risk-averse thinking? Ernst?
If you look at the old times where test pilots had to probe new jets for landing on carriers, the risk was much higher than today we consider as ethically acceptable. Of course, the risk we have seen with the space shuttle was also probably too high. But the societies have become risk averse. That's one of our problems, and it has been addressed in the session on commercial crew activities. And we have to discuss openly about the risk involved in terms of losing important infrastructure, the risk in talking of loss of crew. But of course, it is very important that safety comes first, whatever we do, and we do it rightly, and we take our time and also our money to make safe to get a safe situation for the crews involved. But we have to talk about it, and we have to be aware that we are going to have failures here or there, but we must design a benign infrastructure, a benign system, such that we have enough redundancy to bring the astronauts home. That's the real challenge of such a long venture lasting 20, 30 decades with the same infrastructure to do this. So priority is the safety is the subsystem which has the highest importance. But we have to acknowledge that we have to openly discuss about this.
Let me quote a great Canadian, William Shatner, in response to that question. Forgive the poor imitation, but risk. It's why we're here. It's why we're aboard her. Risk is inherently part of the space exploration experience. And while our very technology, expandable habitats, is designed to enhance the safety of both LEO and beyond LEO exploration, you're never going to eliminate it. But I'd like to address a different kind of risk. Financial risk. You know, it's unfortunate that our Russian colleagues couldn't be here today, because when I would talk to my friends in Russia, they would say, you know, Mike, our billionaires just buy yachts. Yours create space companies. And how jealous they were of that entrepreneurial spirit that takes those dollars at great financial risk and invests them in developing capabilities that challenge the imagination. And the risk of changing a government system and a way of doing business, that you have to applaud what this man to my right has done to take advantage of those entrepreneurs. And that's a risk. So I think we are embracing change, which is inherently a risk, to take advantage of what these brave entrepreneurs and brave civil servants are doing to change the paradigm and push space exploration forward.
I'd like to make a short statement because I think you're right, you both are right. The privatization doesn't contradict risk mitigation, I think. Otherwise, no one of us should enter an airplane anymore. This is, I think, a clear sign that the privatization never, ever has a problem or it creates problems in risk mitigation. This can be regulated at the same time as we do it every time in the world in other sections, I think.
I'd add one thing. We have a chart we've been using at NASA that shows like 3 regions, and one is Earth reliant, and that's where space station is today, and we're developing techniques to to take care of things. And you can get home in a couple hours if something goes wrong on space station. Soyuz is always there. And so it's a good thing in the Earth-reliant region. Then we have what we call the proving ground region, and that's cislunar space. That's somewhere between the Earth and Moon and around the Moon. And that's really, and by proving ground, that's where we need to learn techniques. We need to get experience operationally. We need to experiment with safe havens. We need to look at risk mitigation. Now we're like 5-6 days away from coming back to the home planet, and we're exposed to galactic cosmic radiation. It's a great region to start understanding those risk controls that were really smart, and then we push beyond eventually to what we call Earth independent, and that's when we're ready to go out, and we've now broken the tie back to the home planet. You know, when we were asked to go to an asteroid, even though it's maybe 90 or 100 days away from Earth, I don't think we were ready from a risk posture to go to an asteroid in its native orbit. So we came up with the asteroid redirect mission, and the purpose there was essentially to move an asteroid to a region of space that I think was appropriate with our risk tolerance. You know, we don't fully understand galactic cosmic radiation effects on humans. We don't understand how we can shield or not shield from those. We've got lots of systems we've got to work on, and this proving ground is a great place to learn those skills. So this is one way I think we're going to look at it kind of in a logical engineering sense, to try to gain experience before we just go take that big step. It's exactly what Ernst talked about in as a test pilot, right? When you pick that next data point, right, there's two considerations. Is it too risky to go fly that data point in the envelope because you're there, or is it not risky enough? In other words, we're just duplicating a point we've already got before, and I'm putting the pilot at risk to go just gather another data point. That's not worth it. You got to decide both sides. You got to get that right balance. The risk is big enough to push that it's not foolish, but it's not so trivial that you're not making any advances. And that's what we've got to start talking about openly, is how we balance both sides of that, just like a test pilot does, and we push into this proving ground, and we get comfortable, and we start moving towards that last slide where I showed you where home is really this cislunar environment.
So the golden rule in TV is always close a discussion round, and we are already at the end with something which is close to the heart of everybody. And since we have so many young people here in the audience, I take an astronaut-related question. With all the momentum of commercial flight and the reduced number of calls for astronauts, will there be more opportunities for the young generation to become astronauts, not as tourists, but as actual contributors to the advancement of space exploration? So, hope or fear?
Well, of course, we need the next generations of astronauts, and that is one of the drivers why we do all this, to get the inspiration and the best talents for all the people we need on ground to operate exploration missions. And there are always, of course, also in the future, only a few that are lucky enough to be selected as an astronaut. And looking at the young faces, and I have probed this at my university, each time I start a new lecture, I ask who wants to become an astronaut, and the overwhelming majority is of course raising their hands. That is what we are striving for. And we need for STEM, science, technology, mathematics, etc., we need also the next generation. And only when we have all ready and all well trained and becoming good engineers, I think we should be ready and do what is hard to do, but it is an objective we have to do. And I'm conscious each generation is egoistic enough to do the next step.
I don't know exactly what I would add to that, but I think our field is extremely exciting and very interesting. I mean, the excitement that comes with a spacecraft launch, you know, you've spent multiple decades getting ready for a launch, and you may not be an astronaut, but just as an engineer that's worked on it, or your science instrument, or whatever piece of hardware, you know, you've spent a large portion of your life, and then in a single moment comes that test, right, where the launch occurs and the vehicle flies and it either powers on or doesn't power on. And there's a real sense of excitement and teamwork. The other thing that our field requires is it requires ultimate teamwork and sharing. Everybody has to play full out. You have to be 100% honest. You have to get best ideas from everybody in the group. We don't achieve these great goals as individuals. We achieve them as really a high-performing team that can move forward. And I see that as tremendously rewarding. So if you're lucky and maybe you get to be an astronaut and get to be at the pointy end of the rocket or doing the things out in the fields, but I think it's also just as rewarding to be one of the engineers sitting back in the back that's done all the work and has done all the calculations and the small little pieces that kind of go behind the scenes that are just as critical as everything moving forward. And, you know, and I look sometimes and I think about I'll watch a technician torquing down a bolt somewhere on a rocket, and I know the criticality of that particular bolt. And what that engineer is doing, or that technician is doing, is making sure that that works exactly right. And if that engineer or technician doesn't do their job, the entire mission is lost. So it's not just the person on top, it's this entire team taking every intellectual power they've got, working 100% to dedicate to make these things happen. And that's what's exciting about our business. And we need to figure out a way we share that with folks. And it's not about being afraid of failure. That's not a consideration. You just need to keep moving forward and then be ready to go. And if you have a failure, learn from that failure and continue to press on.
Even us lawyers never underestimate the exciting of getting a technical assistance agreement executed. I'm still smiling from getting our Canada Arm one done last week. And, you know, while I say it half in jest, I, as an attorney, would not have had an opportunity to work on programs like this when I graduated law school. There was no Bigelow Aerospace. There was no SpaceX. There was no Virgin Galactic. There was no CST 100. There has never been a more exciting time to be involved in space development, because for the first time, we're moving beyond the government to the common man. And I look out and I see astronauts in the audience right now, George Zamka, Michael L.A. out there. While I love them both, I want to make them less special. I want to see a day where being an astronaut is common, is something you do to make a living, not an elite core of individuals. And that's what Bigelow Aerospace and Mr. Bigelow are dedicated to, both in terms of outright numbers and the number of countries that can participate. And Bill, correct me if I'm wrong, but on ISS, generally, we have 3 Russians, 2 Americans, and 1 seat. 1 seat for the rest of the world. That must change. It has to change. And we at Bigelow Aerospace won't rest until it does.
Good.
I think this is a good statement, and I think nothing can be done without emotions. To carry emotions, we need a human being, so we have to bring them in orbit as well. So I can't imagine a future without astronauts in the orbit. That's my statement.
Wow. Thank you. Well, please join me in giving a big hand for our panelists. And if I can have the end, I'm trying to give you a bit of a takeaway. I made some notes here, so a bit of a summary, a bit like a conclusion, what we have in a scientific paper usually. So what we heard today is that the ISS is used well beyond its original capabilities. The first crew demonstration of Bigelow's inflatable transportation technology is up for the next year. CubeSats are deployed from the ISS. We understand that it could be like a personal touch when the astronaut is coming and kick out your mission to go into space, and some people really loved it. Obviously, Bill pointed out that the word home is completely different once you're up there. It gets a bit more of a global feeling to that. Patterns of utilizations are important for today's space station, but also for the future space station. It's not space station or exploration. This complements each other. The ISS is a jack of all trades. Still, food is a certain topic, as we've heard. Commercialization can also support exploration. A future ISS is likely to be modular again. Everyone will contribute to it what he wants and what he can contribute. And transition from countries to companies is at least the mindset that our commercial friends have. Take advantage of the entrepreneurs to push space exploration. And astronauts for exploration will be needed in the future. It will still be selective, and Mike is pushing hard to make astronauts much less special than they have been so far. If I get the ping. Yep, good. No, didn't want to have that one yet. Now I spoiled my joke. Okay, tough luck. So this is a picture which is already rather old, but it shows like the space station and its ingredients, because we've talked about exploration today, which of course is the moon in the background. Talking about modular approaches, so we will continue with that piece ongoing. When I assembled the slides, which you've seen from time to time, I stumbled upon that one. That was so cool, and I wondered why these people have such a frightened look. If they look in the future of the past. But then I saw that one, and that explains everything to me. I fly through McDonald's, and we heard about the food issue of the ISS. Makes sense, right? In the meantime, while we speak, the Chinese are building up their space station as well. So this is, so to say, future in being in existence. And in case you want to see that, I checked it. The ISS you cannot see. The X-37 is also pretty bad to see, but the Tiangong one is visible at the moment. So in fact, you could look at it, but you have to get up rather early. That's the disadvantage of that one. And that's, of course, another future in space being right there at the moment. That's Bigelow, of course. And next year, as I said, we will have the tests up there. Before we go up into the future, no, not yet, I would like to give a big thank to our panelists, but not only to them, to the charming ladies who collected the questions, Gia and Charlotte, to all the technicians in the back who made this multimedia presentation possible, to Bernd and to John who coined up the idea, and to all of you for asking questions. Thanks a lot.